Universe's most massive known star imaged with unprecedented clarity. To put it simply, the universe's most massive known star is less massive than scientists once believed. But even docked a few levels, this staggering ball of gas is still the universe's most massive known star. That's how utterly huge it is. Lovingly named R136A1, the luminous giant lives 160,000 light-years from Earth in the center of a stunning, stringy star factory known as the Tarantula Nebula. Last week, astronomers announced that celestial observations collected with the Gemini South telescope in Chile produced the sharpest image ever taken of it, thus unveiling its true heft. For years, data suggested the star held a mass somewhere between 250 to 350 times the Sun's. But according to the team's study slated to appear in the Astrophysical Journal, the new view indicates it's more like 170 to 230 times the mass of our host star. Nevertheless, R136A1 is a gleaming monster. Even with this lower estimate, R136A1 still qualifies as the most massive known star, the research team said in a press release. For context, the Earth has a mass of around, don't think about this number, just feel it, 6,000,000,000,000,000,000,000,000,000,000,000,000,000,000 kilograms. Jupiter's mass is 318 times even that. This all accounts for just 2 worlds in our cosmic neighborhood. And yet the Sun comprises 99.8% of the mass of the entire solar system? If that hurt your brain, another way to think about the size discrepancy is something like 1,000,000 Earths could fit inside the Sun. So, yeah, R136A1 is between 170 and 230 times more massive than the Sun. Do with this information what you will. For the purpose of scientific advancement, this suggests that the upper limit on stellar masses may also be smaller than previously thought, Venu M. Collery, an astronomer at the National Science Foundation's NOIR lab and lead author of the paper, said in the release. Plus, Collery's results might implicate our understanding of certain elements in the universe, particularly those created from the explosive deaths of stars with over 150 solar masses, the ones that went with the biggest of bangs. Okay, but why didn't we know this before? Basically, the universe's most spectacular, scorching and humongous stars are also typically its most fleeting, faraway, and mysterious ones. First of all, really massive stellar bodies tend to exist inside densely populated star clusters that are concealed by residual stardust, like R136A1 resides within the Tarantula Nebula. That makes it pretty difficult for terrestrial equipment to discern precise qualities of a colossal star of interest. Other stars kind of interfere with observations. Giant stars also live fast and die young, according to the NOIR lab, an organization that operates the Gemini South telescope, burning through their fuel reserves in only a few million years. In comparison, our Sun is less than halfway through its 10 billion year lifespan. AKA, there's a bit of a time limit for the already daunting task of identifying supermassive stars within a dust-shrouded star cluster. Here's where the Gemini South telescope comes in. To image R136A1 with unprecedented clarity, this machine used a special instrument called Zorro to get around some giant stargazing hurdles. Zorro used a technique known as speckle imaging, which helped the telescope overcome the blurring effect caused by Earth's atmosphere. Atmospheric blurring poses such a big barrier for telescope observations that, in fact, this was the reason NASA launched the Hubble Space Telescope in 1990. At the time, the goal was to get a lens above our planet's atmosphere for beautiful, clear cosmic pictures. Still on the ground, however, Zorro circumvented the atmospheric blur issue in a different way. It essentially took thousands of short exposure R136A1 images, which were then digitally processed by the study team. Given the right conditions, an 8.1-meter telescope pushed to its limits can rival not only the Hubble Space Telescope when it comes to angular resolution, but also the James Webb Space Telescope. Ricardo Salinas, co-author of the paper and instrument scientist for Zorro, said in the release. This observation pushes the boundary of what is considered possible using speckle imaging. The eventual image conglomerate was sharp enough to allow the team to separate R136A1's brightness from luminescence shed by stellar companions in its vicinity, which led to a lower estimate of its brightness, and therefore mass. Astronomers are able to estimate a star's mass by comparing its observed brightness and temperature with theoretical predictions, according to the NOIR lab. We began this work as an exploratory observation to see how well Zorro could observe this type of object, Collery said. While we urge caution when interpreting our results, our observations indicate that the most massive stars may not be as massive as once thought.
Sick, feeling sicker than you know. Killed a bird without a stone. Talk to throw a bone.